Hi, Ashish. How are you?
I'm doing well, Jose. How are you?
I'm great. Thank you. And thank you for taking the time to answer some questions.
Of course. I'm excited to be here.
Let me start with one that is top of mind for everyone. How are organizations making use of data today compared to the past?
So, Jose, data is used in three different ways in all leading data-driven organizations. One is to learn from the past.
Mm-hmm.
The second is to understand the present in real time. And the third is to predict the future. Now, we have all known about applications around learning from the past. This is all the applications around historical reporting, uh,
Right.
building out reports on what has happened in the past and so on and so forth. But
Dashboards and those.
increasingly, more and more applications that we are surrounded with are working on data to understand the present as well as to predict the future. I'll give you some very simple examples.
Mm-hmm.
All of us, watch services like Netflix and YouTube to consume online content. These services, if you notice, uh, in our feeds, they show up trending content. That is a great example where data is being used to understand what is happening in the present and surfacing that to the users. Similarly, all of these services use our past viewing habits to figure out, to predict what we would like to view in the future and service those concepts. So they surface those types of contents as well. So in my point of view, this is a new norm where data is being used, not just for historical analysis, but also for uh, understanding the present and predicting the future.
Given that this is a new norm, then it must put different types of requirements and pressures on the underlying infrastructure. What are the implications?
The implications on infrastructure are significant.
Mm-hmm.
All the companies essentially are augmenting their data warehouses, which were being used for historical reporting, which is the first bucket of applications that I talked about, with what are called data lake architectures,
Mm-hmm.
which are amenable for the second and the third buckets. When we talk about understanding the present as well as predicting the future, data lakes are the much preferred architecture. And across the board, we see companies augmenting their data warehouses with data lakes. I'll tell you why that is important. When you think about understanding in real time or doing real time analytics, you need to process data as it is coming in. The waterfall way of processing the data and putting it into a structured format for a data warehouse is too slow for that.
Right.
And therefore you need data lakes where those data sets are being dumped in raw into a data lake to enable real-time processing on it. Similarly, data warehouses are great for SQL analysis, but for applications around machine learning and AI, which are important for predicting the future, those applications rely on programmatic interfaces and a lot of open source interfaces. So data warehouses are not sufficient to use there. So across the board, I think companies have realized that in order to adopt these two other buckets of applications, they need to augment their data warehousing stacks with data lake stacks, and that's a significant change for infrastructure.
Now we're talking about a lot of change, right? It might be worth for you to define what is a data lake nowadays.
So that's a great question because data lake as a term is becoming popular, and as
Mm-hmm.
happens with popular terms, a lot of people start calling themselves data lakes. In fact,
Right.
we have come across data warehouses who are calling themselves as data lakes.
Mm-hmm.
But to me, there are certain critical elements that make what is a data lake.
Okay.
First and foremost, the data in a data lake is stored in raw formats. It's not pre-processed. And the paradigm is really storing that data in raw formats and then processing it as needed in an iterative way. Uh, and therefore, the ingest piece in the data lake has to support not just batch ingest, but also real-time ingest. So
And when
that
you
is
say real time, you're referring to streams of data as well, right?
That's right. So data you should be able to stream in the data and make it immediately available in a data
Oh,
lake, which is very different from what data warehouses do.
right, which are
Number
in
two,
batch.
that's right. So both real-time and batch ingest is important, and storing the data in raw formats is important.
Got it.
The second important thing around the data lake is that it has to support different types of use cases.
Mhm.
SQL analysis is important for analysts, but machine learning and AI is important for data scientists. And there's a different ecosystem of tools that it needs to support to do that type of analysis. And the third most important part, apart from these two things, is that data lakes also have to support a lot of governance features. Features like how is the data flowing through the system? What is the source of a data? Data lineage is a very important part of a data lake. Features like figuring out which particular transformation is important and which is not, which particular analysis and ROI or not, and so on and so forth. So governance becomes an equally important part. All these three elements have to be present for you to be called a data lake.
Good. So what are the implications or the most important points to keep in mind when building a data lake now that it's become so prevalent and strategic in the world we live in?
So if you notice, Jose, a lot of the data lake architecture is to promote flexibility, whether it is flexibility of what type of data you store, whether it's flexibility of what type of analysis you do, and so on and so forth. And to me, the most critical attribute to maintain and preserve that flexibility is openness. So, and I'll tell you what, by openness, I mean that all the data which is stored in a data lake should be stored in open formats. All the metadata that is that is part of the data lake should also be in open formats, so that it is not just that data is not just accessible to only one kind of a tool, but it is accessible to different other types of processing. So that is one aspect of openness. Another aspect of openness is that the processing or the workloads that are done on a data lake, they should all be authored in either standards compliant languages or open frameworks. And again, flexibility is a core here. As these open frameworks are evolving, you want to be able to allow their evolution to be brought to data lakes. Openness is, to me, is the most key attribute of a data lake, and openness is what leads to flexibility.
So open data lakes are more significant now than ever, right? Can you give us some examples of why exactly that's the case?
Sure. So Jose, the last decade was spent in defining what an open data lake is and what are the core components of that open data lake. To me, that definition which happened in companies like Facebook's and the Googles of the world is now going mainstream. Now that paradigm is essentially going mainstream, and we see not just these Web 2.0 or cloud native companies that were early adopters of this phenomenon. We now see data lakes essentially going into all different sectors: healthcare, manufacturing, retail, all different sectors. Industry, companies in all of these different sectors are essentially adopting that paradigm. To me, that is a significant change, and I am particularly excited about that now as this concept goes more and more mainstream.
So how is Qubole shaping the future of analytics?
So Jose, our goal is at Qubole is to make this adoption of a data lake faster and faster for any company out there. And we are doing this by taking out the complexity when it comes to scaling data lakes, when it comes to making data lake accessible to a lot of users and different use cases, and doing that in a very efficient way as well. We have done that across the board in clients like Expedia and Newstar, where we, in many of these clients, we have not just hundreds, but thousands of users with different workloads, using Qubole. We have about 200 million workloads in Qubole cut across, data science workloads, data engineering workloads, analyst workloads. So it's a very diverse platform that we have built. And we've been able to do, bring that platform to these companies in a simplified way so that they can really scale their data lake use cases. In addition, we are doing all of this with 50% less costs on infrastructure. So we run data lakes in a very efficient way as well. So our goal is very simple, to keep this acceleration going and make sure that data lakes become a part of every company's enterprise architecture in the future.
Very well, Ashish. Thank you. Always a pleasure chatting with you.
Thank you, Jose.